Good afternoon and welcome to our 2021 training series of webinars. I'm Shirley Lamb and I coordinate the National Building Control Office training. We work with building control authorities, owners, designers, builders and suppliers of construction products to promote compliance with the building regulations. Product suppliers have a vested interest also in ensuring that their products are used correctly in the construction process and not damaged. And where we find damaged or misused products during our site visits, we are now informing suppliers and manufacturers of these products, who in turn are encouraged to promote compliance through education and training in the correct use of these products in buildings. The mission of the National Building Control Office is to promote a culture of compliance with the building regulations in an industry marked by rapid changes in technology and processes. We do this through 5 pillars: compliance support, education and training, which is what we are doing today, inspections, our BCMS system on localgov.ie, and market surveillance of construction products. The building control legislation framework within which we work includes the Building Control Acts 1990 to 2014, the Building Control Regulations, the Building Regulations Parts 8 to M, the European Union Construction Products Regulations and associated market surveillance, and the European Union Energy Performance and Building Regulations. To promote compliance with the building regulations, we support building control officers in the 31 local authorities who are continually inspecting for compliance with the building regulations and building control regulations. Inquiries can be made to the relevant building control authorities or ourselves at support@nbco.gov.ie or to the department at buildingstandards@housing.gov.ie. I would ask that you use the Q&A function throughout this webinar. The Q&A will be provided under the video description or comment section of the video on our YouTube channel, NBCO DCC. I will now hand you over to Jason Horrex, Training Manager at Saint-Gobain Gyproc Technical Academy, who will speak on plasterboards and the building regulations.
Okay, thanks very much, Shirley. I just welcome everyone this afternoon. As Shirley says, my name is Jason Horrex. I represent Gyproc and Isover Ireland. So this afternoon's presentation is predominantly around the Gyproc brand and the use of plasterboards. So Gyproc supply plasters and plasterboards and plasterboard systems across the island of Ireland. My role within the business is training manager. So I look after the 2 Saint-Gobain technical academies where we run a number of courses on a weekly basis across the performance aspects and product aspects that relate to those products and performances from both brands. Obviously recently we've gone online and we're running weekly series of webinars, but typically that would be face-to-face training. So we're going to look at the use of plasterboards and where and how plasterboards can comply with the building regulations. So in terms of what we're going to cover, I've kept it very broad and very basic in terms of the headings. We're going to look at a few slides of where and what they're used for. And then as we go through the presentation, we will look at compliance as products. And then we'll actually end up spending a lot of the time speaking about compliance as systems. And I think that the key message that I want to get across this afternoon is to think systems with regards to how the plasterboards are used with respect to partitions, ceilings, linings, and encasement systems. Not wanting to insult anyone's intelligence, but I'm going to start off with a slide that tells you what a plasterboard is and the sort of the variances that we've got across the range. The bits of information that you have on the left-hand side, let me switch over to the cursor here, just or the laser pointer, make that a bit clearer. The information you've got on the left-hand slide is slightly contradictory to what we've got on the right-hand side. But typically a plasterboard is a sheet material, comprises of a gypsum core, and in many cases a paper liner on the face of that board, and that paper liner can be different colors depending on the types of board and the characteristics of those boards. So we see fire, sound, moisture, durability, and enhanced grounds, all characteristics that can be built into plasterboards. I'm going to call them the common four, but you've got your standard wall board, which is an ivory face board. Your fire line board is pink faced, and that your sound is blue and your moisture is green. Across those four boards, they're sort of industry generic. So whether it's Gyproc or another manufacturer of plasterboards, typically you'll see the same color boards for the same types of attributes. But there are lots more boards within the ranges. I counted this morning, and Gyproc have 20 different plasterboards across the range, and they don't all have a unique color, and some of them are the same as what you would see here. So for example, Duraline would still be an ivory face board. So the front of the board doesn't tell the whole story in terms of the plasterboard itself. Sizes vary. Typical sizes range from 2,400 to 3 meters, but actually in some of the board characteristics, we can come down to 1,219 millimeters, which is a 4-foot board, and we sell them as 4-foot by 2-foot boards in the wallboard variety. Widths typically 1,200, but the likes of plank and core board come down to 598, 600 millimeter wide boards, and thicknesses range from 6 millimeters through to 19. Typical thicknesses are 12.5 and 15 for your most common board scenarios, but there are variants that come down to 6, and there are a couple of boards that go up to 19 millimeters. Where do we use them? We use them everywhere, you know, so in terms of where and how, we use them in simple buildings, basic, you know, domestic buildings. We use them in complex buildings, and they range from residential through to non-residential, industrial, commercial. Just about every single building that goes up will probably have a piece of plasterboard in it somewhere. But what's common, you know, that generally they're all internal applications, and we're using them for walls and partitions. We're using them to conceal as linings, whether those linings need to be performance rated or they're just a decorative lining over the face of a masonry wall. We're using plasterboards to the undersides of ceilings, whether those ceilings are directly applied to, say, a timber frame structure or a suspended ceiling scenario. And we also use plasterboards for the purpose of encasements and protecting steel, stopping it getting too hot, essentially, to maintain its load-bearing characteristics. So if we look at, so that's the where, and what are we providing? We're providing fire protection where it's required. We're providing sound insulation where it's required. Impact resistance, so the boards have an inherent strength. Some boards are stronger than others. We need those boards to receive decoration, whether that's direct decoration or plastering, but the boards need to be of an appropriate characteristic to receive those chosen decorative effects. Some boards will offer fixing grounds. Most boards will offer a lightweight fixing ground, but some boards have characteristics in them that will allow you to fix quite heavy loads to the face of the lining. I'm not going to call it partition system because that could be plasterboard used in lots of different areas. We might need to look at the moisture resistant characteristics depending where we put that in the building. And we also might need to consider the vapor control. So if it's being used to the external facade of the building in conjunction with insulation in behind the plasterboard, then there are some plasterboards with inherent vapor barriers, the foil backing on the back of the boards to contribute in those areas. I know in terms of the introduction, it was highlighted with regards to damages on site and the performance of systems. I'm only going to touch on this in terms of one slide, in terms of some best practice characteristics with regards to storage and the use of the application of the boards, because really when we get into looking at systems, it's about how they're applied to those systems that we'll talk about in more detail. So plasterboards are a flat material, so they should be stored flat, so they should be stored horizontally. They don't like moisture too much. Even the moisture resistant grade boards are only suitable for intermittently high moisture content, so they need to be stored off the floor on suitable pallets and protected from weathering. Very often plasterboards are going into buildings that are not completely sealed. They need to be stored in areas that are away from that exposed weathering. In terms of some basic handling tips, when boards are being used, they should be lifted and separated. One of the biggest sort of things we see in terms of damages on the face of board is where boards have been dragged across the face of each other, and then you start to get paper peel where it's torn the actual paper liner. So just simply lifting the boards from its pallet into the area of operation. Generally, the boards are of a weight where they're a two-man lift. We very often see people lifting the boards as a one-person lift, but it's clearly stated on the back of the boards that it's a two-person lift. And obviously that will aid the risk or reduce the risk of damages on site, and orientate the boards off the ground as well, so that you're not turning them and damaging the corners and the edges or dragging them along the floor. When you move the boards about, they should be carried and placed into position. So as we look at this in terms of, essentially how and where do plasterboards comply? Because they're used in so many different areas, we'll come on to talk about the specific performance characteristics, and we'll look at part B in terms of fire, and we'll look at part E in terms of sound, but they need to be fit for purpose for all of those characteristics. So when we look at part D, and we look at the wording to part D, proper materials means those that are fit for use for the use in which they are intended. So there are decisions that need to be made by the design team as to whether the boards are appropriate for areas of intermittently high moisture, for example, or where they need to offer a greater level of robustness, or even just to achieve those system performances in terms of heights and fire and sound. So we can boil this down into sort of three broad categories. Initially, we need to look at the product compliance as a product. And there's certain characteristics that we need to conform to within the regulations and to demonstrate that they're fit for purpose as a product. There are lots of characteristics that we actually need to consider, that plasterboard is just one component form of a larger system. So we need to look at them as in terms of their system performances and how they integrate with the other components and how they provide those performance characteristics. And when we talk about this point here as a system, we're not supplying a board that automatically offers sound performance or fire resistance. It has to be installed in the correct way. It needs to be undertaken by competent trades. And one of my roles as training manager is to educate all sectors of the industry in terms of how that should be done in the correct manner, using the correct materials. So if we look at product compliance, the first thing that comes to mind is it needs to be manufactured in accordance with a respective standard, and those product characteristics need to be suitably declared. So when we talk about paper lined plasterboards, because there are some specialist plasterboards that are not paper lined and they would fall under a slightly different standard, but most of your paper lined plasterboards will fall under the manufacturing standard, and it's a harmonized manufacturing standard, EN 520. That's been adopted as an Irish standard, so it's ISEN 520, and this defines the methods of manufacturing and characteristics that need to be minimum characteristics that need to be met to be classified as a partition against certain criteria and declared as a certain type of board. So firstly, I'm just going to go through these types of plasterboard, just to very often on the back, or not very often, on the back of the plasterboard and on the relevant literature, you'll find the declaration in terms of the type of board. So they're denoted by different letters, and we've got type A, F, D, H, I, and R. All plasterboards are type A board. To meet that minimum characteristic to call it a plasterboard, it has to meet the characteristics for type A. So your standard wallboard would be a type A plasterboard. But then there are other characteristics that you can manufacture to enhance those boards to give them other performance characteristics. And where these are declared, you won't necessarily see type A because they've already automatically met this minimum requirement and they're superseded by these enhanced characteristics. So for the likes of Fireline, it needs to be manufactured to a controlled density and it has an enhanced core cohesion to act to offer a greater level of fire characteristics. Sound block is a heavier board. It needs to be manufactured to a greater density. Think H as hydro, and there's H1, H2, H3. H1 is the best, and that gives it a characteristic in terms of its moisture resistance. And we can see that other boards form a combination of density, fire, moisture as part of their characteristics. They're declared, those performance characteristics are declared as part of the Declaration of Performance, the DOP. And there are certain criteria that have to be, underneath this manufacturing standard and the Annex ZA within that to ensure that we've declared certain performance characteristics. So we've got the likes of the thermal conductivity of the board, the flexural strength, that we need to declare that it meets those minimum standards, and where it's relevant, water vapor resistance. And I've put in red box here the reaction to fire, the fire classification of that board, because that's something that we're going to drill down into as we go through this presentation. If we look at, obviously boards need to be fit for purpose, and we need to consider where they're being used. Most of those paper line plasterboards will receive a direct decoration, whether that's a painted direct decoration or whether that's plaster being directly applied to that finish in terms of a skim finish. But just to highlight that your boards that have a moisture resistant characteristic, the paper liner is treated. So a bonding agent needs to be applied to the face of the board. If it's, if there is a chosen skim finish or a plaster finish required to the face of that board, then you need to use a bonding agent, and Gyproc have Thistle Bond It, which is a plaster bonding agent which performs an aggregate finish, which provides a key for this plaster to adhere to. That's slightly different to tiling. You can tile directly to moisture resistant wallboards and all of the plaster boards, because the adhesive is more of a glue rather than a key to the face of the surface. And obviously that's subject to the tiling adhesive requirements, and that may require a primer through their own requirements. But in terms of how we set the boards up, they can be tiled directly. It's worth noting, in terms of fit for purpose and, and where boards are suitable. If a tile is too heavy on the face of that paper line board, it's going to shear the paper liner away and tear it away from the face. So there are limitations to the weights and the thicknesses of tiles that are recommended for standard plasterboards, and there are specialist tile backing boards that can be used to increase these weights to a greater degree. Coming back to fire, and I don't want to make this presentation all about fire, but we're going to cover on a lot of points here. If we look at part B and the requirements within the regulations, there are two key areas of part B that plasterboards can offer contribution and compliance. The first is when we talk about the internal linings of the building and preventing fire spread and fire growth. So if we look at the requirements of the building regulations, we see that the linings of the internal linings shall offer adequate resistance to spread of flame over their surfaces. And we do that by measuring that reaction to fire characteristic, and that was the box that I highlighted on that previous slide with regards to that characteristic that is declared on the DOP. This is applicable to all walls and ceilings throughout buildings. Fire goes in an upwards direction, so the regulations don't require the same requirements for the floor, but there are specific requirements for the linings to meet certain characteristics. And if we look at a typical selection of those, it is not everything, it's just a sort of a snapshot, predominantly sort of taking a look at the residential buildings. We can see that we have our national classification of surface spread of flame, and we also have a European classification. I'm sure many of you are familiar with Class O in terms of those requirements, and then below that we have Class 1 and Class 3, and we have the European equivalent to these classifications. I'm going to touch on that in a moment. I'm going to skip on to the next slide, because before I get to that point, I just want to give you an understanding as to why plasterboard performs well within fire situations, but also set out some, for you to understand where those limitations are. The gypsum core inside that paper liner is essentially a pure gypsum. It's a rock that is mined from the ground. Yes, there are a few additives that help to enhance the core cohesion for fire performance or add moisture resistance for the moisture resistant boards. But essentially, you've got a material which is gypsum. That is a chemically combined calcium sulfate and 21% water. Calcium sulfate is inert or non-combustible below 1200 degrees. So you have a non-combustible element to the material as the core, and you've got this 21% water. When it's exposed to a fire, this chemical combined water wants to dehydrate, wants to evaporate out of that board. And that dehydration process is called calcination. But as that fire is evaporating that water, it's using energy from the fire to slow down the rate of growth on the fire, and that calcined layer of gypsum is protecting the layers of gypsum that are in behind it. So as we have thicker boards and more layers of boards, we're actually offering more fire protection to an overall system, but we also have a material within that is going to prevent rapid growth of fire across the surface of the linings. So when we bring that back to those ratings, because we manufacture the plasterboard in accordance with an EN harmonized standard, we don't use the national classification system to rate that board. The DOP requires you to declare that performance under the Euro class system. All, and I underline that verbal comment, all paper line plasterboards will tend to be A2, S1, D0 in terms of that classification. So when we look at the national classification here, we have non-combustible, material of limited combustibility, class O, class 1, and class 3 in that order. The equivalent Euro class labelings is A1 for non-combustible, A2 for material of limited combustibility, and then class O is B, class 1 is C, class 3 is D. So if we reflect back to the table that we looked on 2 slides ago, generally the requirements don't go above class O. There are some specific cases where we need non-combustible, but generally those lines don't need to be above class O. So we can see here that paper line plasterboards across this full range, it doesn't matter whether it's pink, blue, green, or ivory, or another color, it will be an A2, S1, D0 board. So it's a material of limited combustibility. So the linings of your walls and ceilings are in effect compliant. I'm not going to say by default, because there are some variations, because we have to consider laminated boards and the glues that are being used in laminated boards. But if it's just a plain plasterboard, then you have a compliant board. I want to reflect on one area where perhaps plasterboard isn't suitable for use though. So even though it has this A2, S1, D0 characteristic, what's happening to that plasterboard when it's exposed to heat is it's starting to calcine, it's starting to dehydrate, and it's going to crack and it's going to crumble. So if you have linings that are in close proximity or exposed to extended periods of high heat or of high temperatures, that plasterboard is over time going to end up like this. It's going to dehydrate. And we're victims of fashion. We've got recessed skirt, or not recessed skirtings, recessed stoves being put into buildings, and they're not always put into a sort of a brick hearth or tiled hearth. They're put in, and there's an attempt to decorate around the sides of this very hot element. Depending on the distance of the wall and the linings from this unit, those linings could be exposed to those excessive temperatures. So plasterboards and plasters may not be suitable for this area in the back where you have excessive temperatures or high temperatures. When I say high temperatures, technically that's 50 degrees and above. So once we start to have prolonged exposure to 50 degrees and above, your plasterboard is over time going to degrade and eventually crack and crumble away from that surface. So just because it is an A2, S1, D0 lining doesn't always mean that it's actually fit for purpose. But 99% of the time, it does mean that it's fit for purpose. If we move on to the other section of the building regulations that we need to concern ourselves with for for fire, it's fire resistance. So the building cell would be subdivided with fire resistant construction where it's necessary to inhibit spread of fire within the buildings. This depends on the type of building, the purpose group of the building, the height, the scale, the number of occupants within the building. And obviously there are certain areas that are prescribed directly through tables A1 and A2 of the technical guidance document. And there'll be certain elements that need to be under risk assessed by a suitable fire consultant in large and complex buildings. But generally those fire resistances go up in 30-minute increments. And if we're looking at technical guidance document or B, and I'll call it volume 1 because we have volume 2 for simple residential dwellings, it is still acceptable to have qualification to BS 476 and also to EN standards. But no plasterboard by itself is fire resistant. It has a fire spread of flame classification, but you cannot give a plasterboard a 30, a 60, a 90, or 120-minute rating by itself. Fire travels in an upwards direction. Heat and flames go in an upwards direction. But we use plasterboards in ceilings and walls. So we use them in horizontal and vertical applications in different scenarios. So the nature of this fire attacking those different surfaces is going to be different. The plasterboards being used on the ceiling are going to be subject to more onerous conditions. So the plasterboard pallet arrives on site, but we're going to use some of those boards on a ceiling and some of those boards on a wall. So we can't call that board and give that board a specific fire rating because it's going to be attacked to a different level by fire in different scenarios. That's answered that question straight away. That tells you that you can't give, a plasterboard a fire resistance rating. So we can't walk onto site, look at a pink board and say we have a 60-minute system. It's not a 60-minute board. What I want to really reinforce this afternoon is this think systems concept. This guy on the left-hand side is holding this plasterboard. If he lets go, that plasterboard falls to the floor. That means that the fire resistance that was there before is no longer there because the board is on the floor. So when we put this into building terms and we put that plasterboard onto walls and to ceilings, it goes onto a framework. And that framework is a characteristic of that fire resistance performance, whether that's metal, whether it's timber, whether it's a ceiling, whether it's a wall or a lining or encasement system, it provides the support. So the characteristics of this framing system in terms of centers and the materials are going to have an influence. The types of fixings that we use, the length of fixings, spacing of the fixings are also going to influence how well that plasterboard is going to perform in the context of the fire performance scenario. Plasterboards are supplied as a sheet material. They're 1200 wide, they're 400 to 3 meters in height. We put them to line walls, we use them to line ceilings. We have joints in the plasterboard. They need to be treated in the same way or in a suitable manner to maintain those fire characteristics of what is required in terms of compliance with the building regulations. We need to seal around the perimeters. We use other materials within the context of those systems. So we use insulation within the framework of the floors and the walls to offer an enhanced acoustic performance. So we might be using the insulation for other characteristics, but it could have an influence on the overall fire performance. And as we've already stated, we use other materials. So we use timber, we use metal. We think about timber as something that's going to burn, but actually timber is quite good in a fire because it chars around the outside, and that charring around the outside in the same way that gypsum calcines protects the inner layer. So if that timber is of a certain size, when we're measuring it against a certain time period, 30, 60, 90, 120 minutes, that timber could quite adequately be suitable for those periods of fire resistance. But ultimately, what this means is we don't test the plasterboard. We don't declare the fire resistance of the plasterboard. We declare the fire resistance of the system. And we test the system and we test that system against that given standard, whether it's one of the relevant sections of BS 476, depending whether we're looking at load bearing or non-load bearing walls or ceilings, or whether we're looking at EN 1364, EN 1365 for the EN equivalents to those British standards. And we test the system, we joint the system, we stagger the boards, we spot fill the screws. If there's no walking surface going on the system, then it's not tested. It is tested without the walking surface. And the same in the vertical application. We include horizontal joints and vertical joints within the test, so that when this is brought to a larger scale on site, we can qualify the method that's used for the horizontal joints, for the vertical joints. There's a method of putting socket boxes into tests so that we can replicate that a socket box detail can be used on the partition system, for example, if it's built and installed in the same way. And then once we start to see this happening in the laboratory, then we know that we've got a failure of that system, and these wires coming off the face of the system are measuring the temperature. So although we might only have 122 mil wide partition there, there's a furnace raging at 900 degrees on the far side, but we're protecting the occupants of the building on this side from flames and hot gases, but also from the temperature of that fire. And this last point, if it's a load bearing system, obviously has to maintain its structure within that period of time. So we need to think systems. So it's not just the plasterboard, it's the framing, the fixings and the finishing. Yes, your plasterboard provides a significant contribution, but it's not the absolute definitive characteristic of the level of fire resistance that's being claimed. So plasterboards will offer different levels of contribution to that fire resistance. With regards to systems, we can group them in a manner where, like I say, we can detect, in terms of we have the ability to substitute certain boards based on relevant test evidence, so that we know that sound block moisture resistant board performs just as well as wall board. So if we have an area where we have, say, a bathroom on one side of the wall and a living area on the other side, we can swap the boards on one side for a moisture resistant board and still qualify the same level of performance. But we might need to look at the boards in the enhanced category to achieve greater levels of fire performance on those systems. So just to give you an example, and you do need to think systems, and it comes back to the manufacturer's literature. So I'm only giving you an example of Gyproc metal systems here, and across and giving you a quick comparison of wallboard versus fireline, the ivory board versus the pink board. But that could be different for different manufacturers in terms of their studs and their boards. So when you're looking at it as a system, it becomes manufacturer specific, unless we can reflect on, as we'll come to do in a minute, the volume 2 and some of those generic solutions. But just to give you an idea, one layer of 12.5 or 15 mil wallboard, either side of a metal stud partition, gives you 30 minutes fire resistance, qualified to British standard, where the boarding is symmetrical on both sides. If we change those boards to fireline, if it's still a 12.5 mil fireline, it's still only a 30-minute system. But if we increase that board to a 15 mil fireline, then we have a 60-minute system. So again, just come back to the point, just because the color of the board is pink doesn't mean that you automatically have a 60-minute system. And just because the color of the board is ivory just means you don't have a 60-minute system, because if we use 2 layers of 12.5 mil wallboard, we can achieve 60 minutes. If we use 2 layers of 15 mil wallboard, we can achieve 90 minutes. And if we use 2 layers of 12.5 mil fireline, we can achieve 120 minutes. There are fibers in the core of your fireline boards and swelling agents that help to bind the core together, so the board stays intact for a longer period of time and maintains the level of fire separation. There is a comment at the bottom of the slide here: plasterboard linings to timber studs may not yield or may yield different performances. So just because the level of boarding on a metal stud system offers 60 minutes doesn't necessarily mean that the same boarding on a timber stud is going to qualify for the same level of performance. So we do need to look at carefully at the overall build-up. Just as an example there, a standard 3x2 stud with a 15 mil fireline is a 30-minute system. Increase the stud size to 100 by 50 and you have a 60-minute system. So it reinforces that it is a system approach that we need to look at in terms of qualification to the building regulations. And we see that through the presentation of performance literature. So we have qualifications to fire performance within our white book under British standard, and we have equivalent systems qualified to EN standards. And we can see that some of those 60-minute systems to British standard drop to 30, some of the 90 minutes drop to 60. And there are also limitations on the heights that we can build systems to under EN standards that are more stringent than under British standards. EN testing is harder to achieve than British standard. So depending on what the requirements are on the project, very often for anything that's falling under volume 1 of technical guidance document B, which is anything other than simple dwellings, still has the ability to comply to either BS 476 or to EN. And generally we see BS 476 solutions being used because effectively they're more cost efficient. But there are some projects that choose to go down an EN route, and there are some projects that deem it absolutely necessary, and you need to be looking at the appropriate system performances. We might need to increase the boards up to 15 millimeters to achieve those greater heights, where 12.5 mil board doesn't meet those heights because it's part of that overall system performance. Where we slightly deviate from what I've just said there in terms of BS and the EN test substantiation still being applicable is where we move to volume B, or volume 2, sorry, of technical guidance document B, where within the appendix of that document, when it was published in 2017, it said for buildings designed in accordance with the Euro codes, the performance specified must be achieved when tested in accordance with European test methods. But it's still permissible for existing buildings, upgrades to existing buildings to comply to BS 476. Because it's Euro codes, buildings, we can really take that as structural elements of the building. So where the Euro codes underpins part A structures of our building regulations and technical guidance documents. So essentially, if you're building in accordance with the regulations, you're building to the Euro codes, which means that new dwellings need to conform to European test methods. How does that affect plasterboards? Well, it doesn't affect plasterboards in all scenarios because the plasterboard is not always being used to contribute to the fire performance of the system. For example, a masonry wall, whether it's a party wall or external wall, is achieving the fire resistance without contribution to the plasterboard lining that goes inside it. But for the likes of timber stud walls, then the plasterboard is an inherent component of that fire resistance. So just in this very quick overview, obviously, if we've got timber joist floors, they're all load bearing, so they're an element of structure, we walk on them. The plasterboard used on the underside of the ceiling is contributing to the level of fire resistance that we need to offer in an upwards direction. That's 30 minutes typically, but in some scenarios, large buildings, that could be 60 minutes. Timber joist attics historically weren't seen as a load bearing element, but as we consider the likes of trusses and their integral, maintaining their integrity as a truss, and where we need to move up into the 3rd story and we need to have a ceiling above a fire escape area, then we need to treat that as a structural element, and obviously the plasterboard contributes to an EN qualification. Arguably, internal non-load bearing systems don't need to qualify to EN standards, but generally on projects, if it's going down an EN route, then everything gets qualified as EN. But obviously, if it's load bearing, then it does need to qualify to EN standards. And then I've already covered the party walls and the external walls, differences between timber and masonry. And don't forget cavity barriers. Although that's not plasterboard, don't forget that the cavity barrier in that system is maintaining the performance of a load bearing system. So subsequent to the publication of volume 2, we have seen the publication last year, in May of last year, of the supplementary guidance document, which pulled together the 3 circular documents that came in the interim period with regards to acceptable constructions for external walls, party walls, intermediate floors, and truss rafter roofs. So the department, in conjunction with the Irish Timber Frame Manufacturers Association, looked at the methods of construction and deemed that some of those were, the level of qualification on a standard external wall wasn't exactly what we was building, because we're putting counterbattens on the wall, we're building out additional insulation because we need to meet compliance with Part L. We're creating service cavities. So for the floors, we're using web joists and engineered eye joists, and a lot of the test evidence that existed for fire resistance was on solid joists. And then the likes of truss rafter roofs, recognizing that each element is an integral component of that structure, to make sure that that truss remains intact. So the supplementary guidance provides prima facie compliant methods of construction to achieve the required level of fire resistance, whether that's 30 minutes on the external walls, 60 minutes on the party walls, 30 minutes to the underside of floors, or 30 minutes to the underside of ceilings, on the underside of truss rafter roofs, within the context of volume 2 for residential buildings. In terms of plasterboard, and it goes back to where we started in terms of describing those plasterboards by type. I'm not sure how clear this is on the scale of the slides, but the specification of the plasterboards is by type. So we can see here 15mm type A plasterboard or 12.5mm type F plasterboard, 15mm type A, 15mm type F, 15mm type A, 12.5mm type F, 2 layers of 12.5mm type F. So we need to understand what boards meet those compliances. So if we go back to those slides that we looked at earlier, we have wallboard being type A and all boards being type A, but type F, boards with increased core cohesion. That doesn't just mean that it's Fireline. If you remember, we had Duraline on the screen, Habito board. They all have type F qualification. So we can look at alternative boards, providing they meet those characteristics of that EN 520 manufacturing standard. So that sort of brings us to an end on the fire, but we also have Part E of regulations where we're using the plasterboard to help contribute to the sound performance of the building. So under Part E is very sort of focused on residential. So we need to provide a certain level of separation between dwellings, whether those dwellings are basic dwellings, semi-D, terraced houses, or whether we're looking at apartments where we've got both vertical and horizontal separation. We need to consider compliance in terms of airborne sound and impact sound. So if we take any dwelling, airborne sound is relative to all of the boundaries of that dwelling. When we look at impact sound, it's only relevant to the floors. Minimum requirements for airborne sound is 53 dNTW. dNTW dB means that it's a site measured performance as opposed to a laboratory tested performance. Manufacturers publish for their systems, and this is a system approach. The board doesn't have a sound resistance. The system has a sound resistance. But manufacturers publish what is our WDB because you can't test to site conditions because every site is different. So you need to build in a tolerance between laboratory tested and site tested measurements. And generally that tolerance is at least 7 decibels. So when we look at systems where we're providing contribution to a party wall, for example, we'll look at a system that can achieve 60 dB plus in terms of its laboratory tested performances. There's also the requirement to look at impact sound. Impact sound is provided on floors only, looking at where foot traffic is impacting on the dwelling. Just a note at the bottom, just in terms of understanding numbers, for airborne sound, as the number gets higher, it's a better performance, and for impact sound, as the number comes down. Within the technical guidance document for Part E, there are lots of examples of different constructions that should, if built correctly, meet compliance with those requirements for either party walls or separating floors. One of the characteristics I want to point out is that the plasterboards are specified by weight or density. So we can see here for the lining that goes either side of this framed, offset framed lining to a block on flat wall, then there should be a gypsum-based board, so a plasterboard, meeting a criteria of 10 kilograms per meter squared fixed to either side of the wall. We see the same to the underside of the ceiling. So single layer plasterboard with a mass unit area 10 kilograms per meter squared. Just in that context, standard wallboard, 12.5 mil wallboard is only 8.5 kilograms per meter squared. So technically, if you're following the guidance for technical guidance document and you're using these examples to achieve or to get to a point where you can achieve compliance, then you need to be moving to something else like a sound block board or a thicker board, a 15 mil wall board to achieve those 10 kilogram criteria. For timber frame walls, we see within Part E the requirement to have the 2 layers staggered joints of at least 22 kg. That brings you into sound block territory, but we also have to think about the supplementary guidance and the methods prescribed within the supplementary guidance. So we have a 15 mil type A plus a 15 mil type F to meet those 60-minute requirements as part of that Part E wall. None of those systems can achieve their performance without the proper detailing. So I've just got 3 slides just to highlight some of the key characteristics that we need to consider when we're looking and inspecting partition systems on site. First one is the location of those boards. So the boards need to be installed so that they line up with their framing members, but they also need to be installed so that joints between layers and joints on the opposite side of partition systems are staggered. So if I just swap over to the pen very quickly here, if I can get it to swap. The joints on this side of the partition are on here. Stud centers are at 600 mil. Stud centers can be reduced from 600 mil. The field of application rules of test, the fire tests, both EN and British standards, allow studs to be reduced because it increases the fixings and the level of support to the system, and it quotes maximum centers. So generally your maximum centers are 400 or 600 mil for walls, and very often 400 or 450 mils maximum centers for ceilings, because obviously the board is in a horizontal application, needs to be offered a greater level of support. But if we have the joints on this side of the partition on every other stud, on the opposite side of the system, the joints need to be staggered and fitted to the opposite sides. That's the same for timber studs, the same for metal studs. And a lot of these requirements are actually born within BS 8212, which is the code of practice for dry lining. There is no European equivalent to that code of practice. So BS 8212 is where we take the guidance for installation of systems from. We also need to stagger those board joints horizontally. So if we have 2 layers of board and the height of the system is above the height of the board, then we need to create a 600 mil stagger from this edge of the board to this one, and we need to back the outer layer of boards so that we can provide fixing. So typically in a timber stud scenario, that would be a timber nogging. In a metal stud scenario, this will be a flat plate that's used behind the outer layer board to maintain your fixings around that plasterboard at their required centers where we don't have framing in the actual system itself. For ceilings, we stagger the boards. So we stagger the boards in both planes. So we don't have boards, or shouldn't have boards lining up here, because then we've got the risk of cracking running all the way down the ceiling if we have that effect. So we stagger the board joints as best as possible to limit the level of cracking on that system and maintain those system performances. Screws are just as important as the plasterboards themselves. Screw centers. Plasterboard wants to pull itself away from the framing in a fire scenario. And we want to make sure that the boards don't crack or the joints don't crack. So we want to maintain those fixings in the appropriate centers. So we use drywall fixings. We need to make sure that they are the correct length. So where we engage into metal, they need to engage by at least 10 millimeters. And where screws engage into timber, they need to engage by at least 25 millimeters as a minimum. We'll look at the table on the right in a moment. In terms of maximum centers, for vertical applications, it's very often 300 mil maximum centers. In horizontal applications, that comes down to 230. And in some cases, board ends need to be fixed at 150 mil centers. And all of these need to correspond with the framing elements. Plasterboard is a paper lined board very often, and that paper is adding strength to that plasterboard. When screws are put in too deep, as we have here in this diagram, where the screws are put in too deep, that's going to reduce the ability for that screw to hold that plasterboard in situ. Screws should just slightly penetrate the plasterboard so that you get this knurled edge on the paper liner, and it's actually grabbing the paper liner and holding the board onto its framework, whether that's timber or metal. And this is the suitable method of engaging those screws. These centers that I've referenced here are standard manufacturer's recommendations and typical recommendations as referenced in BS 8212. The supplementary guidance or technical guidance document, volume 2, technical guidance document B, sorry, has an appendix A at the back, and it highlights the requirements for screw length and maximum centers. And in some cases, and in many cases, these centers and these screw lengths are longer and screw centers narrower than standard dry lining practice. So in terms of substantiation and compliance for that plasterboard lining used with those details set out within the supplementary guidance, as you see, all of your horizontal ceilings and your ceilings to roof trusses screws need to be at 150 mil centers. And in some cases around your external walls, the perimeter fixings to the plasterboard need to be at 200 mil centers rather than 300 mil centers. So compliance is not just about the plasterboard, it's very much intrinsically about how that is installed. And we either need to reference manufacturer's literature in terms of what their test evidence says, or we need to reference the prima facie compliance and the rules around those characteristics. We also need to tape and joint those boards to maintain the performance. So taping and jointing also needs to be undertaken in the appropriate manner. Use of paper tape typically, to make sure we have an inherent strength. So paper tape bed into the joints with the appropriate jointing materials. However, we have certainly as Gyproc
Jason, you've just frozen there. I don't know if you can come back to us or we'll just hang on for a minute. So just bear with us while we try and sort out. You're back there, Jason?
Yeah, I'm back. I am, yeah. I don't know. One more slide left after this one.
Yeah, no problem. You can
So,
reshare and go back to where you were. Yeah, thank you.
Share again. Were you on the taping and jointing slide when you lost me?
Yes.
Yes. Okay. So hopefully you can see that screen again. So I have one more slide after this, and then the presentation.
Yeah, we can see it there, Jason.
Sorry, Jason, you might have
just on this.
We may have been on the previous slide. Just if you put it up.
Sorry.
There.
Okay. Click back. Screw centers, screws. So
I think that's the slide we were on.
From this slide forward.
Yeah, please.
Okay, I'll take it from this slide. So just in terms of just as important as the plasterboard linings that go onto that wall, whether it's for fire performance, acoustic performance, in terms of sound insulation, whether it's for the maximum heights that you're building the system to, part of that system performance. So we need to use the appropriate drywall screws. They need to penetrate to the appropriate depth. So wearing into drywall screws need to penetrate into the metal by 10 millimeters. Where we're using drywall screws into timber, at least 25 millimeters. The centers of the screws are important. Certainly in a fire scenario, the board wants to pull itself towards the fire. So the more screws we've got at the right centers, the less likely that is to happen and less likely to open up gaps. Same for acoustic. If we reduce the cracking, it's going to maintain the acoustic performance. If we're using partition systems as part of part L for air tightness, again, we want to maintain crack free. And just from the aesthetic point of view, we want to maintain that system performance. So on vertical applications, maximum centers of our screw fixings are 300 millimeters. When we turn those boards into horizontal applications, the maximum screw centers reduced down to 230. And in some cases, board ends, certainly in metal scenario, we need to fix the board ends at 150 mil centers. And these will all correspond with the appropriate levels of framing that we need to provide within those systems. These screw depths and screw centers generally are what manufacturers will test to, because their base evidence is BS 8212, which is the code of practice for dry lining. Don't get caught out by the appendix A to the supplementary guidance. So those prima facie compliant constructions for walls, separating walls, floors, and trusses that are contained within the supplementary guidance need to conform to these sets of screw lengths, depths, and screw centers. And you'll see here that your floors and your trusses are actually at 150 mil maximum centers rather than 230. You see here that the perimeter of the external walls need to be at 200 mil centers rather than 300 millimeters, because that is what was tested by the department and the Irish Timber Frame Manufacturers Association in terms of you need to go back to your raw test evidence to demonstrate that compliance. So it is very much look at whoever is substantiating that performance, whether it's straight out of the technical guidance documents or supplementary guidance, or whether it's manufacturer's literature with appropriate test evidence. What are those fixing centers? And then just the last point, and you can see the arrow on the screen or from the annotation before, paper line plasterboards, that paper is part of the inherent strength of the board. So when screws go in, if they're put in too deep and they puncture through that paper liner and you're just holding it on the gypsum, you don't have the same level of grounds or application to hold that board as tight to the system as when you install it correctly, the screws in correctly. So it just beds into the paper liner and it just knurls the paper liner. So it's actually grabbing the paper liner and trapping that, holding that to your framing system. So all of these characteristics around the screws need to be considered in terms of those fixings. Taping and jointing is just as important as the screws, as the boards. So that method of jointing and filling those gaps to maintain those acoustic performances, air tightness performances, fire performances, crack resistant performances in terms of the aesthetics of the building. So generally systems are tested and substantiated with the use of a paper tape, so Gyproc paper tape, bed in with an appropriate filler finisher. Recently, we have finished a series of benchmarking and we can now say that scrim tape can be used, but only where you have a 2 mil skim finish over the top. So it's not scrim and directly decorate and achieve my fire performance. It's scrim plus a skim finish over the top or paper tape. And paper tape is our best recommended practice because it covers all of those scenarios. And then finally, last slide, we can use plasterboards to offer fire protection to steel, but fire protection to steel is not the same characteristics as fire resistance. So we can't assume that a board that achieves 30 minutes fire resistance on a partition system or a ceiling system is going to offer 30 minutes fire protection to steel. Structural steels come in lots of different sizes and sections. So we've got H sections, I sections, hollow box sections, PFs, post-form channels. They will all have different characteristics in terms of the way that steel is going to heat up. And that's the common factor that we address fire protection to steel. So we assess the section factor of that steel. We look at the length of time that steel requires protection, and then we can calculate against relevant test evidence, whether that's BS 476 or whether it's if I get my numbers right, 13381, for EN standards, the level of protection that needs to be offered. So you need to go back to manufacturer's literature or test literature to determine the section factor. So let's say we have a section factor of 180. We can draw a line across here. 30 minutes, we need category A, we need 1 layer 12.5 mil board. If I want 60 minutes, then I need 1 layer 15 mil board, fire line board, sorry. 90 minutes is 2 layers of 12.5 mil fire line, and then category F obviously is a combination of 3 boards. If the section factor of that steel is different and we're down here, it may be that 1 layer 12.5 mil fire line will do both 30 and 60 minutes. So it very much comes back to not the board, but the steel. And then we can determine what level of board needs to be applied around it. But this is still a system. Your encasement is still a system. The board doesn't automatically offer protection to the steel if it's only fixed with screws every 600 mil centers and it's fixed to a piece of timber that is of an inadequate size. So you still need to have the appropriate framing. You need to maintain screw centers. You need to maintain the jointing of the system, regardless of whether that's a frame system or a frameless system using the specialist boards. So that has covered quite a lot in a small space of time. But there are lots of areas where plasterboard can be used to be compliant with the building regulations. At a very basic level, we can look at the components and the context of the material, but in most cases, plasterboard is compliant with the building regulations when it's used as part of a broader system, and we need to look at the substantiation for those systems to deem compliance with those respective building regulations. Okay, so thanks everyone for attending and bearing with us there. Just a quick plug for my role in the Tech Academy, Saint-Gobain Tech Academy. So a lot of what I've just covered within that sort of 50-minute presentation there, we would expand upon in webinars that we run on a regular basis through the Tech Academy. The 60 or 90-minute webinars either focusing on fire compliance, sound compliance, compliance with the new, well, I say new, but volume 2, and lots of other areas. And we're growing the portfolio all the time. Webinars are free to attend. So just register on the website address that you see there. There are capacity limits. There's 100 people per webinar limit. But say, look at the next date. We tend to try and keep 4 to 6 weeks ahead of ourselves in terms of the calendar. And you're quite welcome to attend and ask further questions on any of the topics that we've covered there today. So thanks very much. And then I think we've probably run quite up to the limits, but I'm quite happy to field any questions that you've got there.
That's great. Thanks a million, Jason. We are gone over time, so there is a couple of questions there. So what we might do is we won't answer the Q&A live here. We will, I'll send the Q&A onto yourself, and if you can answer them, and I'll put them up under the description on the YouTube video when I upload it.
That's no problem. I'll do that.
And so I'm just going to share my screen here. Can everyone see that screen there? Upcoming events 2021?
Yeah, I can see it fine.
Great. So we have a number of events as outlined. Live events will be circulated on our Eventbrite page, and recordings will be on the NBCO YouTube channel, NBCO at DCC. I'd like to say thanks to the team here at the NBCO and to Jason Horrex for organising the webinar today and for your attendance. Goodbye all and take care.